Hello guys, this is Division N6 and today we will be explaining the three techniques of data transfer.
Hello everyone, I am Yash Paryani and I will explain modes of data transfer. In a computer system, data is to be transferred from input device to memory and from memory to the output device. So this data transfer process is done with the three modes of data transfer that are as follows. First, programmed I/O, second, interrupt initiated I/O, and third, direct memory access. Programmed I/O. In this process of exchanging data between processor and the I/O module, the processor does these three important things. First, processor executes the program controlling I/O operation. Second, processor must wait with the I/O module complete the operation. And if the processor is anyhow faster than I/O module, then its time is wasted. So to execute these three things properly, processor issues I/O commands. Four types of I/O commands are received. First, control. It activates every component associated with programmed I/O to perform their required action at time. Second, test. It checks the status of performed operation, whether they are completed or not. It also checks the most recent operation is completed or not. Third one is read. I/O module reads data from peripherals and places it into the internal buffer. The processor then obtains the data by requesting I/O module. Then that data is placed into the data bus and then finally transferred to the memory and stored there. Fourth one, write. I/O module takes data from data bus and transmits the data to peripherals. Means the data is taken from the data storing register and is transferred by data bus to the memory with the help of write as an I/O command. Thank you.
So now, whenever the I/O device sends some data as an input, it sends the data through the data valid cable. The valid data is received by the data I/O interface. The data received is stored on the data register and the I/O interface immediately updates the flag bit. The flag bit is initially set to 0 when the data is received on the data register, then the flag bit is updated to 1. Meanwhile, the CPU continuously checks for the I/O register, that is the status register. It, the lines of code in the CPU continuously fetch data from status register to check whether the flag bit is 1 or not. If the flag bit is updated to 1, that means the data is successfully transferred from the I/O device to the I/O interface. Then the data is ready for transfer to the CPU. But if the flag bit is set to 0, we have to wait for the data to be transferred from I/O register to the data register, and then the CPU will process the data.
So now I am going to explain about interrupt driven IO. One of the way to deal with IO is interrupt driven IO. It is a method or a technique of data transfer which is efficient. It controls the input as well as the output activity, whereas the terminal which needs a data transfer sends signal to notify it. This will result a program interrupt to send, and this is done when the appropriate priority level of IO interrupt is achieved. Relative to the total interrupt system, the processor enter an interrupt service routine. The function of the routine will depend upon the system of interrupt levels and priorities that is implemented in the processor. The interrupt techniques require more complex hardware and software but makes far more efficient use of the computer's time and capacities. So interrupt driven is one of the best way for data transfer.
So I am Parth and I will be explaining simple interrupt processing using a flowchart. Simple interrupt processing is when an interrupt is issued. The hardware part of the flowchart is device controller issues an interrupt. Then processor completes the execution of current instruction. Like the current instruction which is going place will be completed first and then the further actions will be concluded. Interrupt is acknowledged. Then processor pushes PSW and PC onto control stack. Processor loads the new value based on the interrupt. This was all about the hardware part. Then the software part starts, and the remainder of the processor state information is saved. Further, interrupt is processed, and the value of process state information is restored. And the last step is restoration of old PSW and PC.
Myself Hrushikesh Patankar from Group 6, and the third method of data transfer is DMA, which is direct memory access. In this method, the data transfer occurs between input and output devices and main memory directly without involving CPU. For the data transfer, a hardware device is needed called as DMA controller. For DMA to be implemented, processor has to share its system bus with the DMA module. Therefore, the DMA module must use the bus only when the processor does not need it, or it must force the processor to suspend operation temporarily. DMA is a way to improve processor activity and our input output transfer rate by taking over the job of transferring data from processor and letting the processor to do other tasks. It is more efficient to use DMA method when large volume of data has to be transferred. This technique overcomes the drawbacks of two input output techniques, which are the time consuming processes.
Hi everyone, this is Abheerav Patankar. In the previous video, Hrushikesh gave a brief introduction of what is DMA or direct memory access. So in this video, let us look how exactly in the stepwise process form, let us look how exactly is the data transferred from the input output devices to the memory using the DMA controller. In front of you is a diagram of the hardware that is used in this process. So these are your input output devices. This is your main memory. This is the CPU, and this DMAC is your direct memory access controller. This and all of the four are interconnected to the system buses, that is the address bus, the control bus, and the data bus. Now let us start with the process. The first thing that happens is that the input output devices send a DMA request to the DMA controller. Now, to pass any kind of data from any hardware device to some hardware device, you need the access of the system bus. So without the system bus, there's no way to transfer data inside your computer. So the DMA controller passes a bus hold request to the CPU. So what is this? So this request allows, this is a request to get the control of the system buses until the data is transferred from input output devices to the memory. So why is this passed to the CPU? Because the current control of the system bus is under CPU, and that is what the DMA controller wants to access. Now the CPU has to grant the bus access to the DMA controller, but before that it also has to send the data count and starting address to the DMA controller. So what is that? The data count is the amount of data in bytes or bits that is to be transferred from the input output devices to the memory. And what is the starting address? The starting address is the address in the memory from which you have to write data in your memory. So after the data count and starting address is passed to the DMA controller in this process, the bus access is granted. Now when the bus access is granted, the DMA request is acknowledged, and that is sent to the input output devices. Also, the data count and starting address are passed to the input output devices, and finally when the input output devices know the data count and starting address and also have the access to the system bus, the data is transferred successfully bit by bit until the data count is 0.